We're in Beijing, Shanghai, New York, Seattle, LA. We have an office in the city, and our specialty here in Palo Alto is working with startups. So we represent startups all the way from a couple guys in a garage just tinkering to companies that are about to go public. And as an example, some of the companies that we do work for, there's Google, Facebook, Box, Intel, Phil's Coffee, which I'm very excited about, and a lot of others just like that. Now, we also are close to a lot of investors. We work with a lot of angels, it's kind of our specialty. We also know a lot of venture capitalists and accelerators. As we've met along the lines, there's about 55 attorneys here. And if you're doing a startup or you're looking to invest, you're certainly in the right office. And with that, we'll turn it over to the Hive. Thank you.
Thanks. Thanks so much for having us. Hi everyone, thank you for being here. I'm very excited to have John tonight who's going to present about IBM Watson. So I'll try to keep it very short because I know you're all waiting for him to present. My name is Pashu Christensen. I'm the Marketing and Partnerships Manager for the Hive. And just a few words about... okay, no worries. Just a few words about the Hive think tank for those of you who might not know about us. We are one of the largest community of data-driven professionals, data scientists, engineers, practitioners, designers, artists, all focused on big data. We started this community about 2 years ago. We have hosted about over 60 events. We have over 6,000 members. We are part of the Hive think tank members. And we hosted over 150 speakers. Take good notes of our upcoming events. Next one is in Oakland on the East Bay. First one that we're going to host there at Pandora. And then we have another one on December 3rd, and we might have another one on December 10th. So anyway, if you want to know about our upcoming events, make sure to follow us on Twitter, #HiveData. And you might also be notified for our upcoming events on our media group, as you should all be members here. We'd like to thank our sponsors tonight, of course, Perkins Square for hosting us, and our partners. Just a few words about the Hive. Usually Ravi, the founder of the Hive, does this presentation. He unfortunately couldn't come tonight. But the Hive is an early-stage data-driven startup incubator. We are a low-volume, high-touch studio, and we incubate, fund, and launch big data companies, early-stage startup developing applications for businesses. We are mostly focused on marketing, CRM, IoT, healthcare, and security. So if you're an entrepreneur, if you want to reach out to us. If you are interested in funding a new company in that space, please feel free to reach out to me. My email is pashu@hivedata.com. These are some of our startups. Also, we are hiring. All our startups are hiring. Foghorn is one of them. And for tonight, please continue the conversation online. You can take pictures, you can comment using the #HiveData. And with this, I'm going to pass the microphone to John Wolpert. So I'm going to read your title because it's pretty long. You're a product line manager and evangelist for Watson ecosystem at IBM Watson Group. Is that right? Okay, thank you so much.
Am I live?
Yeah, perfect.
Well, thanks. Wow, a lot of people. So that's cool. Actually, I think my official title on LinkedIn, and feel free to link me, is Seeker of Awesomeness, and that's actually my official title, like on IBM's internal systems, is Seeker of Awesomeness. The story there is that this is my third time at IBM. Just really quickly about me, I've been a startup founder 3 times, and over the last 3 decades, since 1989 when I got a cow. And I've been an IBMer 3 times. So one of the great things about Silicon Valley in the early days, back then, you might have heard about Terman, the provost of Stanford, kind of made the Valley. I think the single biggest thing that Stanford did was let professors go and come back, leave, get smarter, come back, leave, get smarter, come back. The revolving door policy which actually isn't as common as as it might be out there in academia. Carnegie Mellon's doing a good job of that, but IBM's doing a great job of that. So we boomerangs constitute a good chunk of the company, and proud to be a three-timer. So and when I was coming back to IBM this last time after my third startup, my boss said, "Well, what do you want to call yourself?" And I said, "Oh, Seeker of Awesomeness." He said, "Okay." So that's my story. I am not going to do slides. Is that okay with you guys? I have them, but I'm not going to use them. Instead, I'm going to do kind of a chalk talk. So a lot of people here write code, right? Code. A lot of people here run companies. Okay, so that's the kind of group that I want to talk to. So we're going to talk about. Remember that movie Apollo 13? So it's funny. We talk a lot about moonshots here in the valley, right? Not a lot of them are about the actual moon. I was at NASA the other day, and I was briefing General Warden, who's a super cool guy that runs NASA Ames, and he said he reminded me that IBM research had a lot to do with the actual moonshots, the one to the moon. I thought that's a good use of IBM research dollars. Today, a huge chunk of IBM's $5 billion in research goes into cognitive computing. And that's the subject that we're going to talk about. But I was also reminded when I was there that there's a story that came out of Apollo 13. There's Gene Kranz, the flight director, said famously, or at least Ed Harris, who the actor that played him in the movie, said, "I don't care what a thing was designed to do. I care what it can do." So what I want to go through today is what Watson was designed to do, and then what you can do with it. So I want to think of this as Watson is not a single monolithic entity, a cognitive singularity or something like that. It's not like that. It's really a whole bunch of Legos, and we're going to make them available to you to build your own Lego spaceships with. So that's my job today, is to give you some amount of precision about what Watson, or what the things that compose Watson can and can't do. And then I want to do a lot of Q&A so that you can leave this room and do something, and not just go, "Oh, I think I understand what cognitive is about now." So that's the job that I'm trying to do today. So what was Watson designed to do? Well, originally Watson was designed to win Jeopardy. Right, that was what we designed it to do. It was called a grand challenge, and the previous one was try to win chess against Garry Kasparov. And we did that. Interestingly, though, and I was in grad school. This was 95, 96. And I watched that, and it was a big deal, right? Who saw that game? It's cool. We didn't do what we did with Watson, though. We didn't create a new line of business at IBM. IBM very rarely creates a new division of the company. But after we won Jeopardy, something different happened. We created a $1 billion new division of the company. We haven't done that since 1992. The last time we did it was when we created IGS, IBM Global Services. We do okay with that business. So we make those kinds of bets very rarely, and they usually are transformative, and we usually are doing them around a fundamental transformation in technology. We think that 2011 marked that the shift from effectively programmatic, deterministic systems, von Neumann style systems, right? We've all been doing for the last 50 years 5 things, right? Loops, conditionals, right? 5 things. That's all we have. Everything on everybody's iPad, your phones, 5 things. That's all we do. In infinitely beautiful complexity, but still 5 things. Today, we're pivoting over to non-deterministic systems. And why? Because we can. Because just the same way that Bose headsets were possible at a certain point in time when computing could handle noise cancellation in a small form factor with low battery consumption, you could almost plot when you would be able to create noise canceling headsets. Right now they proliferate today. But there was a point where computing was just too expensive, too hard. You weren't going to be able to make a commercial noise canceling headset. I think in a similar way, today the power consumption, the level of compute that could be handled on these really non-trivial, expensive algorithms, some of them. We can handle them today. So the big story, the one that most people won't tell you about, is what's behind Watson, what's behind the cloud, the fact that we're pumping a lot of energy into making it affordable and scalable to run machine learning algorithms and cognitive computing. So 2011 marked that point where we thought, hey, we were able to take what was a room-sized computer, Jeopardy, and turn it into LPARs and now into virtualized systems. So it's a big deal, right? Who does machine learning here? Who does? A lot, right? So I mean, some of these, we can always work on the algorithms, but they aren't, not all of them are n log n, right? Some of them are really, quadratic at best, right? So these are expensive algorithms, and they require a lot of compute. We can do that now. So Watson was designed to win Jeopardy. It had to do 5 things. I'll talk about at least 4. And I challenge you, as I'm telling you about what it was designed to do, think about what you could do with that capability. So capability number 1, it had to understand and disambiguate deliberately cryptically phrased questions, right? It's Jeopardy, right? They're not going to make it easy for you. A question like, in the linking category, and I'm paraphrasing a little bit, Seward has submitted this, or has submitted this to me 3 times, and by God, now I'm going to accept it. Now, a junior high school student would say that the answer was a friend request, because they aren't running temporal analysis and don't realize that Lincoln was not in an age where Facebook would work. So a friend request, logically correct, right? Submitted, accepted. Of course, it's a friend request. Watson got the answer right, which was a resignation. So that's a deliberately cryptically phrased question. Watson had to understand that feet smell and up is that way and up yours means something different. And so regular expressions, big dictionaries, but more importantly, being able to run statistical analysis across huge volumes of English language content to determine relationships between concepts. That's the first thing it did. And I have to admit, that particular capability, as an entrepreneur, I have a hard time thinking what I would do with that particular Lego. I mean, I don't usually deliberately cryptify my questions, right? So if you think of something where you need to disambiguate deliberately cryptically phrased language, let me know, because that'll be an interesting use case. But it's there. It had to be able to do that, and it's interesting. So click, there's one Lego. Second thing it had to be able to do, I think is infinitely more interesting. It had to be able to bring back salient content based on a query from 200 million pages of text, 60 million documents, with no links in it. So think about that, right? Ever since I failed to hire Larry Page in 1998 I was really into seeing if he could come to work for Allen and research at IBM, and they weren't interested. PageRank and its children have dominated the scene based on popularity ranking, right? So you have to have links. You have to have a crowdsourced way of determining, effectively, in this case, popularity as a proxy for salience. Well, in a body of content that has no links in it, how do you do that? Who works for a huge company? Yeah, I know you do. Who else? Right? Have you ever tried searching on your intranet? Right? It's terrible, right? It's not because your CIO doesn't know how to deploy Lucene or Solar, right? It's not about the fact that you don't have good search technology or indexing. It's that who writes links in their Word document and PDF. Without those things, you don't have any way of generating salience. You don't have any way of determining what is the right body of material to bring back from whatever query you're looking for. That's a big deal. Watson did that in under 3 seconds every time a question was asked in Jeopardy. It had to query 200 million pages of text and generate hypotheses about what the right answer was, concatenate those things, build models, argue with itself, effectively, a bunch of subsystems basically arguing with each other, saying, I'm right, no, I'm right, no, you're right. And then finally, rendering an answer with confidence in under 3 seconds and buzzing in. So that's a big deal. Third thing it had to do is Jeopardy, by design, penalizes you if you don't get the answer right. So if you buzz in and you're wrong, you lose money. Part of the game. Consequence of having to design for that is that we have this third Lego, which is confidence score, and not just a score of saying this is the popularity of this content from the query, but really a very nuanced, interesting confidence score based on lots of subsystems that are all trying to vie with each other for confidence. So, for example, there's a subsystem that's handling temporality, right? There's a subsystem handling location, so there's time, there's location, there's semantic analysis. There's 350 subsystems represented by even more algorithms. Some of them fairly esoteric, some of them what you would expect, gradient descent and its kin. All working to argue with each other about what is the right answer, coming back with that confidence score. So what would you do with a system that brings back salient information and can give you a confidence score of some sophistication about why it thinks that's the right result? And notice that I'm trying to avoid two words that I don't like: questions and answers. I don't like those words. They limit the mind. So I'm trying to I'm trying to sort of get folks to think about what they could build for themselves, because at the end I'm going to show you how you can actually build stuff for yourself for free right now. And if you're going to do that, I don't want you limiting your mind. And I think that the words question and answer personally do that. So I don't like to use them. I like query and a return, a result, right? Because that's what it's really doing. It's not like you have to form a question. Jeopardy did that, but that's not, you don't have to put a question mark at the end. You can actually just put in stuff. And I'll show you a really interesting example of that in a minute. That's the third thing, so confidence score. And the last thing, the fourth interesting one that I think is really cool is, and this probably isn't a surprise to machine learning folks, is that it's designed by if you ever put a large paragraph of text into a search engine, you get a mess, right, most of the time. It's fun, but you get a mess. With Watson, within reason, I don't want to overplay this because there are limits to this, but within reason, Watson systems, depending on which one we're talking about, I'll show you several, will bring back salient information based on high feature set queries, meaning sentence or two or three or more, depending on the context. That's cool, right? That means I can, so for example, and I'll show you right now, this is Watson working in oncology. This is, let's see, I'll just pick one. This is live. I'm risking live. I'm risking live on an open internet where all of you guys are tweeting at the same time, so forgive me if it hangs. But this is a patient record. What the Watson team does, since we created the division, is we've got a huge team of researchers, thousands of people, that are building all sorts of machine learning, cognitive computing systems. And then we put them together with, in this case, MD Anderson, Sloan Kettering, Mayo, or Baylor University, and we say, hey, there's a big problem. People are dying from cancer. Let's work on that. And we build what you might say is a bespoke system. This is a custom-tailored big system that we built for MD Anderson, and it's helping them save lives today. And then what we do from there, and I'll show you this in a minute, is we take that and break it apart. We say, hey, here's this big giant Lego ship that we built for MD Anderson. We're going to snap this piece off, and we're going to make it available as an atomic service for you to use. So here, here's a set of, and I've already got 7 Legos that you can use today. And here, what ship would you make out of it? But this is the first ship we made. And I hope everybody's getting the Lego references. Is that not universal? Okay. So in this case, it's feeding, it's consuming about, if I remember correctly, about 71, several thousand journals and millions of pages of patient records and other data, 23 million Medline articles. And it's basically consumed that, ingested it, and then we ingested all of the MD Anderson cancer EMR data, so electronic medical records. And remember I said that you could do a long query. Well, this is a great example. I'm going to feed in the entire. I could put some notes in here. Here are the attributes of this patient, and I can say, well, it's he's got regional lymphoma, and this is recommending the course of treatment and the timeline. This is actually less interesting than some of the other ones I can bring up, but you get the idea. Watson's actually generating a course of treatment and a diagnosis from a long form electronic medical record, plus notes, plus all the doctor's information on this patient, background information, information about their preferences in healthcare, genetic information, past medical history, family history, all of that's going in and rendering a result. Famously, fairly recently, and then I can go in and look at the rationale. Why does Watson think that this is the right answer or the right diagnosis? Not too long ago, one of the doctors thought that Watson was wrong, was about to hit the "you're wrong" button to teach it, not to give, to figure out what's going on there. And he looked at why Watson generated that answer, and what Watson had done had consumed a more recent clinical study that he had read himself. An oncologist has to read 750 pages of text a week to stay current. Can't do it. So it turns out that this was, in this particular case, it was the right diagnosis, and we won't claim that it saved a life, but it certainly saved pain and suffering on the part of the patient. So that was pretty cool. So in this case, I think what's even more important is that, I don't know if this is a little known fact, over 50% of clinical trials in America go unfilled. Not enough people. Way more than that. Percentage of people with cancer that could get into a clinical trial never find their way into the right one. And so what this is doing is consuming the clinicaltrials.gov database and matching the patient right there in the room to the right clinical trial. And I think that's huge. So that's an example of what you can do if you can provide a long form query into a system like Watson that can then bring back relevant content. Notice I didn't ask any questions. I didn't say, Watson, do you love me? There was no questioning involved. There was a great user experience designed by people who knew what the problem was and brought back life-saving or otherwise hugely beneficial information at the right moment, at the right time. We're really close to Xerox PARC. Anybody remember a guy named John Seeley Brown? He used to run Xerox PARC back when I was coming up in the 90s. And JSB is like the authority on knowledge management. And I was briefing him on Watson the other day at his house, and I said, he stops me and said, what Watson really is, as a movement, is an operationalization of what we've been talking about in knowledge management for years, which is taking large bodies of information, applying expertise in a systematic way, and then taking that and using it in a specific circumstance to solve a real problem at the right moment. And that would be a knowledge. That's converting information to knowledge, so in a way, that's what Watson's doing. But we didn't stop there. We thought, well, while we're at it, why are we just trying to solve the problem of answering questions? Why don't we find out what the questions ought to be? So we went to Baylor University and built what's called Watson Discovery Advisor, which is also kind of a SaaS bespoke system. And we said, in the hands of scientists, let me back up. I used to run a research consortium in Australia. It was really interesting. We had life science researchers and we had polymaths, and we would embed them into many, many companies, many legally separate entities. What we were looking for was opportunities to work together where Company A had, say, maybe an orphan project, and Company B had another orphan project. Together, they're like the answer for warp drive or cure for cancer. And it was really fun. The problem was, and I wonder if anybody else has felt like this in their lives, we always had this aching feeling like we just didn't know what we didn't know. Do you ever get that? Well, this was a really interesting problem. We said, well, what if we fed Watson all of Medline, 23 million articles at least? That's a good chunk of it. So about, I think half maybe. So we fed it 23 million Medline articles, and we said, what questions, effectively, what questions should we be asking of this data? And Watson came back and said, well, let's just talk about colon cancer and genetic causes of colon cancer. And I happen to know something about this because that research consortium I was working on happened to work a lot on kinases. Does anybody know what kinases are? So in short, a kinase, yeah. This is Anthony, my colleague. I'm going to introduce him in a minute. He's way smarter than me, and is now on the Watson team, and also one of the best programmers and developers in San Francisco, and the winner of the Google challenge, the first Google Android challenge, and all sorts of really cool things. And one day he said, you know, John, you're actually working on something I would actually work for now. And so a month or two later, he's on the team. I'll introduce him in a minute. And so a kinase is a really simple, is a protein that adds or takes away a phosphor from other molecules in the cell. And sometimes when this happens, it results in bad things happening. So there's another gene called, or a protein called P53, that when things go wrong with P53, bad things happen. That it's associated with about 80% of known cancers. And colon cancer is especially implicated with P53. So when it goes wrong, things go wrong. And all of the kinase researchers in the world for the last 30 years have found 30 kinases that are likely to have impact on P53 and on oncogenesis, on cancer. When we fed Watson these 23 million articles, it found 6 more kinases. In some reports, 7 kinases that when we went into the lab and tested, turned out in fact were causing cancer, or were implicated in cancer, in colon cancer specifically. And so it found the question to that and the answers, without being asked, which was really kind of cool. It was answering the we don't know what we don't know question. We weren't asking, are there more kinases? It found preemptively 6, 7 more kinases, and it turned out that they were, in fact, truly implicated. This is one of the subsystems that was used in that work. And so this has actually never been done. It may just look like a nodal graph, which is easy enough to do. I'm sure lots of you have done them. But this was done entirely by Watson with no programmer, no data scientist, no scientist creating structured data out of it. It was purely on the language of 23 million unstructured articles, human language. And I kind of predid this because I was worried about the network, but this is basically taking these articles and saying, you know what, MLH1, which is one of these kinases, relates to TP53 by phosphorylation, and then it goes into the analysis. It's a little bit wonky to look at, but from a science, if you're a scientist in this space, this is revolutionary because you would never have seen this. The punchline of all this is that thousands of kinase researchers together didn't know what each other knew. Watson was able to see them all at the same time and find 6 more opportunities that they missed in between. That was cool. And I'll show, so, and these are the articles. So instead of like doing a keyword search and saying kinases, phosphorylation, P53, even knowing that you should put MLH1 and P53 into the same query, that was the missing link, right? They weren't thinking about that. And Watson said, hey, wait a minute, MLH1, P53 related by phosphorylation, let me look at that. And here are the articles that it used to determine that relationship. Now the cool thing, now that's all kind of great if you're a scientist and if you're working at Baylor or at MD Anderson, but if you're a startup, what are you going to do with that? This is a big system. We built it. It took lots of researchers, lots of time and money. Well, you might have seen that we have, let me jump in here. I was signing out. When we did that work, even scientists now are getting really good at building in a SOA way, in an API-centric way. So we were able to take the subsystems from Discovery Engine and turn them into stuff that you could use. So I don't know, who's seen Bluemix yet? So Bluemix is IBM's PaaS, Platform as a Service. And it's also like the most modern way that we now can release software as a service to the world. We can do it way faster than we ever did. It's transforming like vast tracts of IBM software group. I love it. It's like the fastest, easiest way. I'm lazy as a programmer, and I don't have much time to do that even when I get to do it. Anthony, would you agree? So getting to do, you're not as lazy as I am, but getting to do, to use Bluemix is just so much easier. It's also cool because it's backed up by a soft layer, and so we own the whole stack all the way down, so we can cost optimize, we can do things that I think are pretty cool. But from perspective of Watson, it also turned out to be the fastest, easiest way for us to get these subsystems out to you. So one of the things that the Discovery Engine had to do was find co-occurrence and create structure out of all that unstructured data. And one of the systems is called concept expansion. So if you go to the catalog in Bluemix, and it's bluemix.net, and you look at, you go down to the Watson, so you can create, you've got runtimes, Node, Java, Ruby on Rails. You can create your application and basically hit play and run it, right? So it's a DevOps deployment platform. But you can also then add Watson services right out of the box, and these are all in beta and free to use. And I'll say more about that in a minute. So you take, for example, user modeling, and you can go into it. You can look at the docs. You can try it. You can bind it. Go in, and create. This is actually important. If you actually try this and you don't want to actually write your application in Bluemix, all these services are available. Just get the key and the API for the coders in the room. Get the so to get the endpoints, get the key, leave it unbound, and then just reference it externally. So it's kind of a nice thing, and it's sort of you have to know that. So I wanted to say that so you weren't confused. And it's in beta right now, and you create, and now you have your service running, and you can utilize it as you wish. This particular subsystem is doing psycholinguistic analysis on structured text. This is one of the things that we built for some of these bigger systems like the Discovery Engine and other systems. And so in this case, we said, well, why don't we put Herman Melville's Moby Dick into Watson, or into user modeling, and this is how Watson sees Herman Melville as a person. Wow. So kind of a sexy graph, but actually the important thing, I kind of think of this as like the next generation Myers-Briggs, right? So I'm encouraging my colleague, who's the product manager of this, to maybe really double down on that idea and build a line of business around that.
Where did the data source come from? I mean, where's Watson reading these meanings from?
Right here.
Yeah.
I just plugged it in. If you want to give me your blog, I can plug that in and see what if you're brave.
Like a bio, you can put some.
Put anything in there. One of the things that's missing that I just full disclosure, I'll talk out of school here. I think what would be cool is, there's lots of great literature on why this is happening. This is all based on psycholinguistic analysis, as well understood field in psychology. And what I would like to see is if you click on this, go back and see the markup and see why Watson was actually making those determinations. That would be cool. It's not there yet, but it's possible, so they're working on it.
I don't know if you already asked that, but is there a way to access to look at that?
Right now, like you could leave, don't leave, but you could leave right now and start building on this right now for free. Just go to bluemix.net, log in. You don't even need a credit card. For 30 days, you don't even have to put a credit card in. After 30 days, it asks you for a credit card, but as long as you don't consume any services that cost money, you'll never get charged. So, finally, weirdly cool for, yeah.
To what extent does Watson use semantic technology and open source software?
So I get asked, the question was, to what extent is this open source software? And and not for nothing, I was in the room when we made the decision to go to Linux. That was a big day for us. So we very much an open source group, and I actually ran AlphaWorks back in the 90s, if you remember AlphaWorks. So we were like open source before, we were openness before open source. Companies need to learn openness before they learn open source. And very proud to have been sort of on the early firing line of that. This is openness insofar as we're opening the APIs, but with billions spent on these subsystems, we're not going to open source them today, at least. So forgive us for that, but we do it slowly and with some great deal of consideration. So when we don't do open source, we're doing it for a reason. But we do make it openly. The APIs are openly available, and in a minute I'll tell you about how we're actually not only making them open, but how we're investing in the companies that build stuff on cognitive computing. So you can get this stuff, you can